Slicing strings is something that's very nice in Python that you can do. And it's a little tricky at the beginning, but if you concentrate on it, it looks very much like the rand range that we used when we were generating random numbers and the range function that we were using with the for loop. So basically you have a string and you want a part of the string. So if you just say string and in square brackets, you put an index, you get one letter, right? So if I have a string and I say location 0, index 0, it gives me the first letter. Now, what if I want a series of characters? So I want a part of the string. So let's look at here. We have a name, Patty Lynn Smith. And what I want to do is I want to go to this name and I want to get 6:10. So when you have two numbers, just like the range or the rand range, the first index is the first location and the last one is where you're stopping. And it doesn't include the stopping, right? It doesn't include the 10. So this is saying go to name and start getting me the characters starting at location 6. So if I start counting, P is 0, 1, 2, 3, 4, 5, 6. So L is at location 6. So the first character it's going to give me is L. It's going to start giving me until it reaches character 10, not including 10. So this is 6, 7, 8, 9, 10. The 10 is the space. It's not going to include the space. It's going to only give me up to N. So if I print here that variable middle, I'm going to get the L, Y, N, N. Index 6, 7, 8, and 9, 4 characters. Now here, notice here, I'm again calling on name. I didn't put anything, and then I put a :5. When you don't put a value for one of these parts, it just assumes that like it's not there. So here, if I don't put for the start, it means just start from the beginning, basically, start from 0. And so here I'm asking for the name starting at location 0 from the beginning until I hit 5, and I don't include 5. So it's going to give me the P 0, 1, 2, 3, 4, 5 is the space, so it's not going to give me the space. It's just going to give me Patty. Here I have the starting, and what am I missing? I'm missing the end. When it misses the end, when it's leaving the end blank, it means go to the end of the string. So it's going to start with location 11 all the way to the end. So this was 5, 6, 7, 8, 9, 10, 11. So 11 is S, and then it's going to give me till the end of the string, the Smith. Now, what if I just say colon without anything in between? So here it means start when it's blank, it means start from the beginning, location 0. When the second part is blank, it means go up to the end. So this is basically going to give me the full name from beginning all the way to end. Now here, I'm going from beginning to end, and then I have a third value, which is the increment. And here it says 2. That means it's going to go and give you index 0. And then after it gives you index 0, it's going to add 2 to it. So it's going to go to location 2. So it's going to give you the T. After the T, it's going to go add 2. So it's going to give you the Y. And then the L, N, space, M. And so you're going to get every single letter. And so this is a really nice thing that you can do with strings to get parts of the string or like every other character in a string. Another thing that we can do with strings, like we said, concatenation, we could use the plus or we could use the plus equal. So for example, here I had, at the beginning, I had name and last name, and what I did was I created a full name. I could also do something else. I could have here name, let's say 1, okay, str equal to my first name. And then what I want to do is I want to append or add to str. So I'm going to say go to str and add to it a space. And then go to str and add to it my name. So this is very similar to when we're having numbers. You know, if I have a number x equal to 9, and then I want to add to it something else, I say x plus equal 2. So what I'm doing is adding to x the value 2. So now x becomes 11. The same way here, I have a string and I'm adding to it. So initially it's my name, then it's going to add a space to it, then it's going to add my last name. And so if I print str, I should get my full name. Let's comment out everything at the bottom so it doesn't get printed, so we can actually see what we're doing. So here, the last thing it's printing is the string that we just created, and it prints it as we've shown. So I can do plus, or I can do plus equal, which we were used to using with numbers. Okay. Another nice thing that you can do with strings is use a keyword called in. And what in does, it checks if something is part of the string. For example, let's say here I want to know if the letter I is in my string. So I can say if, for example, str, and I found an I. Another thing I can do, for example, is if I have, let's say I have a string like place equal to Manchester CT, and I want to know if this place is in Manchester. So I can say if this word CT is in place, place is in Connecticut. Okay, so in both of these, I will get that I found an I and the place is in Connecticut. Now, if I have place 2, and place 2 is, let's say, Hampton, Virginia, and now I say if CT in place 2, I'm not going to get this print message. So let's add an else. Else print not in CT. And one thing about what we're doing, the in, it's case sensitive, and I'll show you in a minute. So here it's going to tell me not in Connecticut. If I go back and change to, this to place 1, and I change this to just lowercase ct, it's not going to find it. Sorry, place. So here I'm checking if place, if ct uppercase is in this place, it's not going to find it. Why? Because it's case sensitive. The comparison is case sensitive, but so it said not in Connecticut. But if I change it back to be uppercase CT, then in this case, it will actually find it and say it is there. So we can use in, we can also use not in. So one thing we could do, for example, banner ID, let's say someone put their banner ID as this and they forgot the at. So I can say if at not in banner ID, if it's not in it, I'm going to tell them invalid banner ID, invalid banner ID. And so here with this, I'm going to get the message that it's an invalid banner ID because they forgot the at. So you can use in to check if something, a series of characters, is in a string. And you can use also not in to check if something is not in there. Another thing that you can do is use the repetition operator, which is the multiplication symbol. And what it does really, it just prints something multiple times. So if I come here and I say print me banner ID times 5, what it's going to do, it's going to print this number 5 times. That's all it's going to do. So it printed that 5 times. Now this is a little hard to see. Maybe let's print place. Let's print the place 3 times so we can actually see it easier. And so what it did, it printed Manchester CT, Manchester CT, Manchester CT 3 times. Notice that it doesn't put any spaces. It's just printing them all next to each other. So that's something else that you can do with strings. What else can we do? We can do string comparisons. Just like we can compare numbers. If 2 numbers are, bigger, smaller, equal, we can also do string comparison. We've seen string equal comparison before, like the while loop when we wanted to see if the user entered a yes or a no. But you can also do less than or greater than. Now, how does less than and greater than work? Basically, it works alphabetically. So here, if I come and I say, let's say word 1 is banana and word 2 is apple? Which one would come first in the dictionary? So in the dictionary, apple comes first. So that means apple is smaller, okay, because it comes first, so it's going to be smaller. So if I ask if word 1 is less than word 2, it's going to give me a false. Print word 1 is smaller, else print word 2 is smaller. Okay, so here if I compare banana and ask, is banana less than apple? The answer should be no, it's not less than apple because it doesn't come before it in the dictionary. So I should get word 2 is smaller. So let's try that and confirm. And we do get word 2 is smaller. Now, one thing about comparison is that it's case sensitive. And lowercase letters and uppercase letters are not the same. Everyone is stored in as a number. And lowercase letters come after uppercase letters. So in the ASCII code, which is how letters are stored, uppercase letters come first, then lowercase letters. So what does that mean for us? It means if I have a word that is uppercase, it's going to always be letter smaller. So here, let's just copy those 2 words again, but we're going to make them 3 and 4. Now, 3 and 4. And what I'm going to do is I know here it told me that word 2 is smaller. Before it told me word 2 is smaller, apple is smaller, right? Now, if I change this B to be uppercase and run this code, actually I need to duplicate the code, and 4. So let's now test 3 and 4. And, you know, if someone just tells you, test word 3 and 4, banana and apple, you would say, oh, banana comes after apple. So that means banana is bigger and apple is smaller. So I should get word 4 is smaller. However, that's not what we get. We get that word 3 is smaller. And why are we getting that word 3 is smaller? It's because that B comes before A. Why? Because uppercase letters come before lowercase letters in the ASCII table. Okay, so the only thing I want you to know, you don't have to memorize that uppercase letters come before lowercase letters. But what I want you to know is that when you are comparing words, you need to kind of make sure that they both are the same case. They're both all uppercase letters or lowercase letters, the whole word, or they both follow the same syntax where they're both starting with an uppercase letter or they're both starting with a lowercase letter. But if you start testing and comparing words that are not the same case, then you're not going to get the accurate results.